My name is Joris Peels, and this is another edition of 3D Printing News Unpeeled, courtesy of 3dprint.com. Welcome. So today, the best 3D printing news, the most relevant additive manufacturing news brought to you live. So what do we have today? We've got Luxembourg-based AM4AM, which is a company that makes powders for powder fusion, is launching a new aluminum or aluminium, depending on where you're from. So it's called HyperAl or HyperAl or HyperAl. So it's a zirconium derived 7000 series aluminum. So similar to the 7000 series we all know and love. And it was developed by AM for AM together with Cirrus and LIST as part of the Horizon 2020 European funding for new technologies. The idea here is that it's developed specifically for the 3D printing as a process, or powder bed fusion as a process, and it's specifically meant to develop or make crack-free parts and have improved mechanical properties. And at the moment, they disclose that they have 500 megapascal yield strength, 465 on UTS. And that's made possible by their cold plasma technology. And the cold plasma is, there it is, that technology will allow them to make many more different alloys and different other materials in the future. We all know the advantage of aluminum, of course. Powder bed fusion runs very, very fast in the machine. It's a very widely demanded material, and but there is a reason, of course, that it the Inconel and titanium are much more often used in 3D printing, and that's because it's traditionally been difficult to run on the machines, and it's particularly been a bit overlooked, I guess. So there is really potential there in aluminum. I think that's a really exciting material for them to work with. Especially because aluminum runs so fast in the machine, the parts are far less expensive than parts being made with other powders that you can't run that quickly. But a little proviso. I mean, first off, I love the fact that they're doing this. I love that it's a small Luxembourg-based startup that's really coming up with really new materials. But if we see companies entering additive, right, they often want kind of like a worm safety blanket kind of. They are already doing something that's really scary for them, making these parts using this new technology. They already have to implement this new technology. So they often kind of, out of security, or maybe because they have to from a regulatory body, or maybe because they're always used to using this one material, they always fall back to wanting 316L or whatever the materials they're used to working with. So that safety blanket is really important to them because there's so much is new and so much is scary. And sometimes they can't even switch. So as we've seen also with Scalmalloy, which is another wonderful material, like adoption can really take time and really needs kind of like, you need to kind of socialize the adoption. You don't need to market this material. You kind of need to socialize the adoption a really limited, very critical group of people. So I'm saying, I love that this is happening, but I think the proviso I'm going to give here is that, first off, please give me pictures of your product. And the second thing proviso I'm going to make is that, to get adoption and to drive adoption, it's going to be very difficult for this company. Also, because a startup, what guarantee do you have that they're going to be around 10 years from now, as opposed to like the Praxairs and the Huguenots and all these other companies that are much more established. So I think it's going to be an uphill struggle, but I love that we're seeing real innovation in this space. So what we have here, this is actually a picture from a Boeing facility. This is a different Boeing facility. This is the Boeing Interiors Responsibility Center in Everett. It's an LSAM machine, and it's a really, really large tool they made for, I think, a 777 or other aircraft. We had to use these pictures because the news we have now is of the opening of a different facility, and that's the Boeing Additive Manufacturing Plant, or BAM, which is in Algona, Washington, which is a bit due east of Tacoma, apparently. So we didn't have any pictures of that facility, but this will show you what they're doing there. And because it's at the BAM plant, they have a BAMily machine, which is the LSAM Thermwood, and that's one of the things they're doing there is printing tooling, like the part that you see in front of you. The Boeing at the opening of this plant, which is, they actually kind of opened it before a couple of years ago, but then COVID and other things, and so now they talked about using a trim fixture for winglets, which is the things save energy on the end of your aircraft. If they would outsource it, it would take 6 weeks, right? Now with 3D printing in-house, it's 41 hours of printing. And then post-production is another 85 hours. I love that they split this out because a lot of people realize that, post-production is sometimes so intense, especially for these kinds of tools that have to be dimensionally quite accurate and also be very, very smooth. They also say that traditionally they would pay somewhere around 50, 60K for this tool. And the AM tool is available for them. The one, not the one in front of you, but another, the other one, which kind of the tool for this winglets, would cost them 40K, which still sounds very expensive to me, by the way, but still is a considerable cost savings for them initially. Um, so Ms. Orma said at the facility that they don't have the luxury of stuffing decades of data with things like castings. Um, and the challenge is amassing data, which they are doing, to give regulators a level of comfort with 3D printing. So that's, and they're doing that through a lot of testing. So that's absolutely fantastic on their part. They also talk about that they're using it for internal parts for the Starliner aircraft, winglets for tooling for the 737. Also, these kind of large tools is probably what they're mostly doing with the technology at the moment. But there's also another thing that they disclosed, which I did not know, and that is for the Whisk. The Whisk is a kind of autonomous air taxi. It's part of this new revolution of electric aircraft and also autonomous aircraft being used for passengers. It's one of these things that if this happens, it could fundamentally change a lot of things, a lot of people, how they commute. It could make, say, a suburban community 100 kilometers from a major town viable. It could, it could do a lot of things. It could change a lot of things. But these are kind of long shot technology investments. And for here, Boeing is also turning to 3D printing. Now, what surprised me is for this thing, what they're 3D printing is a 12-foot diameter um, passenger compartment part. So this really kind of shows how great the Thermo's kind of engagement with Boeing has been for them. And I think it's also really good for Sabic, because Sabic, as I remember correctly, bought an LSAM machine a long time ago, and also we're investing heavily in developing materials for it. But imagine, all our desktop 3D printers humming away, and one of these LSAM machines spitting out kilo after kilo of material for the tooling and parts like this size, right? So they, the Sabic has like, Ultem, filled Ultem grades and stuff like that, which work quite well in these kind of roles, especially since, it's electric aircraft, so there's no jet fuel. So that could be really excellent for Ultem or PEI, as it is also called, polythermite. Yeah, I love this development. I love that Boeing is being a little bit more open about what they're doing in Additive. I love that they really seem to want to be driving this revolution as well. We're seeing a lot of like really large defense and aerospace companies in America, kind of present their 3D printing chops lately, and I expect a lot more coming soon. So this shows that there may be some money in the offing uh, uh, right about now. Okay, so the next news is Bauer, which is a Canadian company that makes sports equipment, mostly for like hockey, but a bunch of other stuff as well. Worked together with Twicket to launch an app. This is an in-retail personalization experience called GameFit. What you do is you tell them what kind of helmet you need, the name, the age, your experience, and your hair thickness, which I'm not entirely sure I would know my hair thickness, but anyway. Um, and then the store associate, so presumably in like a sports authority, does that even exist or anymore? But anyway, in that kind of sports store would then take a iPad, just a regular iPad, with this app on it, and then scan you to point you to the right helmet. So I love this. So first off, it uses a lot of powerful consumer technology, the iPad. The other thing, Twicket, which is a Belgian-based mass customization company, is showing how they can be used as a decision-making tool. And later on, we could easily see how Bauer could use this in a 3D printed helmet kind of application as well. At the moment, it seems like it's just a decision guiding tool to guide the person to choosing the right helmet for them. But one could easily see it working with helmets specifically because, like, I think pretty much every helmet company in the world should be working on 3D printed helmets just because the advantages they provide over kind of like a random foam by giving you programmable kind of performance in terms of the types of impacts you can expect per sport or activity. So I love this kind of thing. I also like that, like, we could look at mass customization, which has been talked about a lot and done very little. But as a kind of a burden to capture this data, oh, we have to do this, or we could look at it as an experience. But I think the true value for Bauer is not only this even experience or this decision guide, right? But the true value to me is that I can walk in and maybe the associate says, hey, you know what? Could we scan your feet as well, or just your body generally? No need to be naked or anything, but just like, scan your body, right? In that sense, right, what Bower would have, right, would be the scan data showing you what your actual size would be, right? And that would be super valuable if you gave the company that access to that data, or if they could share it with people. That would mean that every time you're on Bower.com or whatever, I don't know if they have Bower.com, but their retail, their online experience, you would be able to get the right fitting clothing. You need a goalie jersey. This is the goalie jersey for you. You need shin protectors or whatever. This is the shin protector for you, and you'd never have to return an item to Bauer because it didn't size you correctly. So to me, that is the ultimate value, especially since a considerable amount of shipping is people shipping stuff they don't want anymore, or that doesn't fit them back to retailers. So I think this is a really exciting technology for now because it works, but it points to a future where life is easier because you get scanned at one point, and it points to that being very valuable in my opinion. Um, I don't know why this is happening. Sorry, just a second. Okay. I don't know why this is happening. Sorry about that. Uh, okay. Well, anyway, sorry about that. Glidewell is developing a micro CT scanner. So Glidewell, let's see if we can get the next slide to work. Sorry about this, guys. This one does work. So sorry about that. So Glidewell is making a micro CT scanner. So this is really remarkable. I love this as a news item. So Glidewell is a giant dental lab. They have over 400 3D printers, and they print all sorts of things for all sorts of dentists all across the US and the world. Glidewell is known, and Ankush Venkatesh, who runs 3D printing for them, has told us a little bit about this at Additive Manufacturing Strategies, also on our 3D pod. He was a guest there, and he told us a little bit more. And he told us about how Glidewell kind of is very vertically integrated, and also just like really wants to create the tooling it needs throughout its processes. And he told us this, but I had no idea they went this far in this. So what they did is they developed an in-house micro CT scanner, right? And it's made specifically for 3D printing parts, for QA inspection, and just looking at and digitizing essentially parts for dental. They made this thing specifically for them. So they made it to be really, really quick, and they made it to be quite affordable. They run 100 of these things in-house, right? They scan hundreds of thousands of parts on a yearly basis. So you bet it's optimized for that task. And what they can do now is they can scan at 50 micron in 30 seconds or a minute, right? What they can also do is in a workflow that if you remove the part, once you remove the part, the file is being processed already, and you can put the new part in the scanner already, so you don't have to keep waiting. They also made a quite desktop compact type of scanner, which is quite small, which suits their needs, and I think will suit a lot of needs. Like imagine like in a lab or in an engineering company to have a company like a product like this. It'd be very, very exciting. We really need, I've time and time heard again about how slow CT scanners are, how incredibly expensive they are, and how do we need them for all sorts of products, from developing products in order to also to doing quality on products. So this kind of thing could be really, really. I loved also Field. They're also doing something in this area as well. They're making this technology more affordable. But I love the fact that Glidewell's selling its own equipment into into our industry. So I think it's going to be really fantastic for them, and they could then use the money to develop more things, which then differentiate them from and make them more efficient than other dental labs. So I think strategically this makes a lot of sense. I don't know what's wrong with my slides today. Okay. So what we have is that DB Schenker is looking at an on-demand production solution. So DB Schenker is it's a logistics arm of Deutsche Bahn, a large German train company. And DB Schenker in its own right is a gigantic transport logistics company. So what they've come up with is a digital warehousing solution, which is looking at identifying parts, scoring these parts, making the business case for additive, deciding which parts are good for additive and which ones aren't, and then putting them in a secure digital warehouse, which will let you then decide which parts to print, and they will then be printed close to the location where you need them or where your customer needs them. So I think it's fantastic for a company to be moving into this area. I think it's fantastic for somebody to have the capability of doing this. And I think it's fantastic move, I think, for them to compete with BASF or Pleek on making this possible. And I would hopefully expect also UPS, FedEx, Kuehne and Nagel, and all sorts of other companies to do similar solutions as well. To me, it makes a lot of sense because they can still do delivery for these parts, albeit shorter, and they can capture a lot of value from this whole 3D printing process. And they can help a lot of companies that have no design capacity or no OEM capacity or no real 3D printing initiatives to adopt this technology without having to adopt it. So any kind of facilitation like that makes a lot of sense to me. So I really, really like this. I think it's a great move that we'll see a lot more of. The next is Barcelona's CIM UPC Technology Center, which is a part of the University of Catalunya, I think there. They previously were the part of the university that spawned BCN 3D, and now they've made another 3D printer. This is a direct write 3D printer, two print heads. So one print head, there's a lifting head, so you can use the two heads in combination. They call it Power DIW, and it's aimed at the research community. It's open, and you can add different tool heads. So you could put an FDM or a pellet extrusion system or SLA on it. At the moment, it's basically a syringe system that's capable of operating at 800 Newton. And I love direct write. We all see a lot of research come out in direct write. There's a lot out there because it is such a good technology. If you want to essentially want to lay down or deposit or organize or make something out of like a new substance, direct write is a really, really very versatile technology for doing this. And then they're going to try and make another system. There aren't many systems here available. There aren't many low-cost systems available. Most of the systems that could do this kind of thing are very, very expensive. So I like that they're doing this. I think it's also a very valuable thing to the 3D printing community, but also generally a lot of disciplines, anywhere from ceramics, metallurgy, 3D printed circuits to tissue generation slash bioprinting. I think this is a kind of tool that would really kind of democratize direct write for a lot of people, making more prevalent. I think a lot more companies in our industry should be looking at how to make direct write printers rather than sit and try to make a FDM printer for left-handed people or whatever. So I think this is a really fantastic technology. The next news item is that BASF, the chemistry giant that is never very far away from us, whatever part of whatever thing we touch, it has probably been somehow made indirectly or directly by BASF. And the company that's also invested considerably in 3D printing has started a 3D print catalyst, right? This is fantastic. I love this because there's a lot of stuff going on in factories, in kind of process chains where we're doing slight optimizations and that have really big effects in energy consumption or yield or something like that. And nobody ever talks about these things because if a company commissions someone to do that, they often keep it secret because it's a secret or because it's some really internal process thing that they don't want to put out as a press release. So I think this is an absolutely fantastic product that exemplifies a trend that's kind of underground in 3D printing. What BASF is doing with this rather simple looking thing is they're 3D printing a catalyst with an open structure, open geometry, which gives it a lot more surface area. Now this high surface area, right, means that the catalyst reacts faster and the pressure drop is reduced, which improves the overall performance, might even improve the speed or the yield or whatever the overall economics of this plant are improved through this really simple addition of this shaped catalyst. Now, what gets even better is that BASF can change the inflow pattern, the directionality or the orientation of the fiber, and then can get really specific catalyst geometries, right, or infill geometries for you, for your plant, for what you need, for your specific outcome. They can then produce energy with this. They could you could maybe even get a better chemical, or you could get a higher yield, which of course, given how much money they put in these plants, any kind of really small performance tweak can have really big effects on their profitability. BASF has used this stuff internally. Now they're going to supply everyone. They're starting with sulfuric acid catalysts, 2 of them. And these are one of these things that we don't really sufficiently consider, I think, but at the same time could really have a big impact on the world. So I think this is fantastic news. And of the things, this is the biggest impactful thing, I think, because of just a small effect could have a really big consequence. And also, this is something maybe you didn't wake up this morning thinking that would happen, right? I think also the glide well micro CT scanner, you probably didn't expect either. I didn't anyway. Forward me, that was amazing. Yeah, so really great news, Dan. I'm really enthused by all this. Really, really enthusiastic about all this. So thank you so much. And yeah, and I hope you enjoyed it today. And have a great day.